So in problem 1, it asks us to find an equation for the function f of x in blue. The first thing we should notice is that this looks like a trigonometric function. So let's start writing out our function equation here. Now, these sort of curves we notice going back and forth in a repetitive manner remind me of a sine or a cosine graph. And how do we tell if it's a sine or a cosine graph? Well, sine will start, let's draw another graph here. The sine graph starts at 0. So it looks like this. Boop, 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 and it finishes at 0 as well when you finish one period. That's the length it takes to complete one cycle of a sine function. And the period of a cosine graph is exactly the same, but it starts at the top, goes down to its lowest point, and then goes back up to the top. Notice that our function, f of x, more closely resembles the generic cosine graph because it starts at its highest point, reaches its lowest point, and implicitly will finish at its highest point again when it finishes one period. So f of x is some kind of cosine graph. The next question we have to ask ourselves is, what kind of special numbers are going into this? And when I say special numbers in this equation, I mean numbers that tell you how tall or how long or how quickly the graph is changing. Well, we've already talked a bit about the period, and in a regular cosine graph, the period is 2 pi. In our case, notice that the halfway point is pi over 2, because the halfway point of a period is the lowest point on the graph. So if we were to complete one period, it would take us to pi instead of 2 pi. That means that the period of our graph is half the period of a regular cosine graph, or a generic cosine graph. So how do we represent that when we're talking about our f of x function? Well, let's think for a minute. If we were to plug in some value of x, say x is equal to a half, into a regular cosine function, that would get us to where? Well, here's pi, so half pi is right there. That is pi over 2. It takes us a quarter of the way through. But in our function, it takes us halfway through a cycle. So it's almost as if we plugged in 2 times as much of that x. That x counts for twice as much in the period of our function as it does in the period of our generic cosine function. To visualize that more clearly, try plugging in pi over 2 to the function cosine 2x and also into the function cosine of x. Next, let's talk about amplitude. Amplitude is the height from the 0 to the highest point of a trigonometric function. In our case, the tallest point is 2. And in a generic cosine function, the tallest point is just 1. So how do we represent that? Well, the principle is similar to when you're looking at just a linear function. In a linear function, say y equals x, the slope tells you how quickly you're increasing. For y equals x, the slope is 1. But if you make it more steep, say slope equals 2, you get to the same point, like say you want to get to y equals 1, you get to the same point twice as fast. Similarly, we're moving twice as steeply as normal because we're getting twice as high when we hit our x equals 0 point. So that implies that the amplitude 2 should go out in front, telling us how steeply cosine is changing. In summary, our f of x function is, in fact, expressed by f of x equals 2 cosine 2x. Thanks for listening.